Okay, day 2 of section 5.2. Today we're going to be working with the intercept form, the x-intercept form at that, of a parabola. And it's really the same basic concept that we've been doing. We're going to be graphing parabolas, but I'm sure you can see at the very top of the notes here, this is looking considerably different. We have our A out in front. It's the same A that we've been working on. If A is positive, our parabola opens up. If A is negative, our parabola opens down. The vertex of a parabola, as we've been talking about, is the highest or the lowest point on the curve. But finding it now is going to be a little bit trickier. What we're seeing is we have x minus p, x minus q. If I were to let x equal p, p minus p is 0, this whole expression would cancel out to 0. Similarly, if I were to let x equal q, this entire expression would cancel out to 0 as well. That means our y values would be 0. And what we find is that when our y values are 0, we are on the x-axis. We will have an x-intercept. So what we have here are x-intercepts of p and q. What we're going to see is that our vertex is going to have its h value is going to be the average of these two x-intercepts. So find our x-intercepts, add them together, divide by 2, and that's where our vertex is going to be located. The axis of symmetry is going to be the line x equals h. It's a vertical line. So if I may, let's very quickly take a look at this first problem. We're going to graph this parabola, and we'd like to first find our x-intercepts. Our x-intercepts, what you do is look at each parenthesis and ask yourself how I would get 0. Well, we could see that with x plus 1, the opposite of a 1 would be negative 1. So I'm going to say we have x equals negative 1 for our x-intercept. In fact, if you let x equal negative 1 plus 1 would cancel out to a 0. Another way we can envision this is that this is really like x minus negative 1. It's kind of like x minus p, if you'd rather. Similarly, over here with x minus 3, if we were to just let x equal a 3, the 3 minus 3 would cancel out to a 0. In other words, look what we're really saying we could do. Look at the parentheses here and choose the opposite sign. I have a minus 3 here. That's going to correspond to having an x equals positive 3 for an x-intercept. I had an x plus 1. That's going to correspond to having an x equals negative 1 for an x-intercept. Now our vertex is going to be an x value, but it's going to be the average of those two x-intercepts. Negative 1 plus 3 is 2. 2 divided by 2 is 0. I'm so sorry, 1. Silly me. Well, what we're going to do, sorry about that, is very quickly just let x equal 1. That's our x value of our vertex, but we're going to get one step bigger, one step smaller, one step bigger than the 2, and one step smaller than the 0 as well. And from here, we're just going to treat this exactly as we've been doing. We're just going to plug in these x values and see what we get. If I were to plug in a 1, you can see very quickly I've got 1 plus 1 here, and I'd have 1 minus 3. Again, you could even let your calculator do this, but let's be honest. 1 plus 1 is a 2. 1 minus 3 is negative 2. 2 times negative 2 is negative 4. Hey, let's go ahead and plug in a positive 2 as well. 2 plus 1 and 2 minus 3. Well, 2 plus 1 is a 3, but 2 minus 3 is negative 1. 3 times negative 1 is going to be negative 3. We could just as well plug in a 0. And then as we do that very, very quickly, you can see that you'd have a 1 times negative 3. Here's your negative 3. And here's that symmetry idea that we keep talking about. As we mentioned earlier at the very beginning, if I were to plug in a 3, yeah, 3 plus 1 is 4, but 3 minus 3 is 0. We're going to get a 0 down here. And very similarly, when I plug negative 1 into that, we already said this is what our x-intercepts are. We know that when I plug negative 1 into that first parenthesis, I'm going to cancel that out. So look at this. The intercepts are going to help us out. They are, in fact, going to correspond to 2 points. Well, our vertex is going to be a point. It's the point 1 comma negative 4. Our axis of symmetry is going to be the line x equals 1. Now, plotting 1 comma negative 4, 1 to the right, go down 4. 0, negative 3, we're going to just go down 3 steps. 2 comma negative 3, we just come down over here. 3 comma 0 is right over here. And also negative 1 comma 0. Very, very quickly, we are going to see our parabola taking shape. And very nicely, you can see that we are done. We've got our vertex and our axis of symmetry. All right, well, let's take a look at problem number 2. Okay, so let's take a look at example number 2. Again, just going through the same basic procedure. What you do is you try to find your x-intercepts first. In this regard, if we're looking for our x-intercepts, we can see we've got 2 little parentheses here, this x plus 1, and also the x plus 3. And of course, we've talked about just plugging in the opposites. If you see a positive 1, x plus 1, you might wonder if negative 1 is going to be an x-intercept. Indeed, it will. If you see an x plus 3, you might think about using negative 3. That's a wonderful choice. To find your vertex, again, this isn't the full vertex, which is an x and a y coordinate. This is just the x coordinate. It's the average of your 2 x-intercepts. And negative 1 plus 3 is going to be negative 4. Negative 4 divided by 2 is negative 2. So what we do very, very quickly is we build ourselves a table around the value of x equals negative 2. We'll get 1 step bigger, 1 step smaller. Notice that these are your 2 x-intercepts. We're also going to get 1 additional step bigger than negative 1, 1 additional step smaller than negative 3. Well, plugging in a negative 2 here, you can see very, very quickly, negative 2 plus 1 is going to be negative 1. Negative 2 plus 3 is a positive 1. 1 times negative 1 is negative 1. Negative 1 times 2 is negative 2. So we'll actually have a y value of negative 2 as well. Just a moment ago, we talked about the x-intercepts. If we allowed x to equal negative 1, you can see in that yellow highlighted section up above, that whole parenthesis would go to 0. And 0 times anything is 0. Very similarly, plugging in negative 3 into that green parenthesis right there, that would make that whole entire expression arrive at 0. Once again, look at the symmetry that we're seeing. We could also plug in x equals 0. X equals 0, well, not too hard to work that out. 0 plus 3 is 3, 0 plus 1 is 1, 3 times 1 is 3, 3 times 2 is 6. You might not be too surprised to find out what you get when you plug in a negative 4, but please do check that this is in fact the case. What you definitely want to do is make sure that you're not just blindly using symmetry. Should you ever make a mistake, this is your opportunity to catch it. Negative 4 plus 1 is negative 3. Negative 4 plus 3 is negative 1. That multiplies to a 3. 3 times 2 is a 6. So, plotting these points, negative 2, negative 2, 2 to the left, down 2. Let's see, negative 1, 0, negative 3, 0. 1 to the left, and then 3 to the left, not moving up any. 0, comma 6, that's just going 6 steps above. Negative 4, comma 6, 4 to the left, and then 6 steps up. Once again, look, you get a very quick graph, and you can see that we have a nice axis of symmetry going right down the middle. You always are going to see these y values duplicating. So what's our vertex? Our vertex, as we just saw, was negative 2, comma negative 2. And our axis of symmetry, very simply, is x equals negative 2. Coming over here to number 3, what x-intercepts would we have? Well, you'd have x equals 2, x equals 5. And if that were the case, you can very quickly add 2 plus 5 is 7. So your vertex is going to be 2 plus 5 is 7. 7 divided by 2, you'd get 3.5. That can scare kids sometimes. They're thinking, wow, I must have done something wrong. No, you didn't. You don't have to be too concerned about that. That's actually completely normal. We're not going to have enough time to completely finish this, but just to let you know, here's 3.5 that you're going to use for your x-coordinate. You can certainly get a half step bigger, which would only go up to 4, and then a half step smaller, which would go down to 3. Then get one full step bigger than 4 to go up to 5, one full step smaller at 2. Real quickly, what you're going to see is at 5 and at 2, if you're really thinking about it, those are your x-intercepts. You know that that's going to arrive at values of 0. Hey, plug in 3.5. Sometimes this is what can bug kids a little bit. They're almost like, well, wait a minute, isn't this going to get you some fractions? Yeah, you can see that that's actually going to be perfectly okay. 3.5 minus 2 is actually going to be 1.5. Let's see, 3.5 minus 5 is going to be another 1.5, except this one's a negative. But a negative times a negative is a positive. Another way to look at this, 1.5 is really 3 over 2. 3 over 2 times itself is 9 over 4. So that's 2.25. Your calculator could help you out with that as well. Very, very quickly, we're running out of time. If I were to plug in, say, a 4, we'd get negative, and here's 4 minus 2 times 4 minus 5. 4 minus 5 is negative 1. It will cancel this other negative. So we're going to be left with 4 minus 2 is a 2. And then by symmetry, we would need a 2 over here as well. With only about a minute left to go on our video, 2 comma 0 is over here, 3 comma 2 is up here, 3.5 and then 2.25. You just have to kind of estimate that. You're not going to get it perfect. 4 comma 2, well, go 4 steps to the right, go 2 up, and then 5 comma 0 would be right over here. Should you like to get more points, you certainly could. What's your vertex? Well, your vertex is 3.5 comma 2.25, and then your axis of symmetry is the line x equals 3.5. So we rushed through that. We only have about a minute left on our program to record the video anyway, but it deals with this worst case scenario of, hey, what happens if our vertex winds up being a fraction? You can see what we did. We just made a quick adjustment by going a half step up. Hope this helps.